Good afternoon. Thank you for joining us. I hope you're enjoying the OpenStack Summit. We've actually joined together here with Rogers and Red Hat to present a SD-WAN based on open source. And joining me actually as part of this presentation, I'm Azhar Saeed, by the way, I'm one of the chief architects in Red Hat, is Jaffer, who's also chief architect at Rogers.
Hello.
And Hanan Garcia, who's the telco solutions architect in Red Hat.
Hello.
So what we would like to do today is actually walk you through a concept that we've been playing around with Rogers in their lab for some time. And what I would like to do is hand this off to Jaffer to talk through the first requirements and presentation and what his thought process was, and then come back and talk to you a little bit about the design, and maybe at the end we can show you a quick short demo. Jaffer, over to you.
Good afternoon, guys. For the third day of the conference, everybody's exhausted and ready to go, but we thank you for your time, and hopefully this will be some beneficial and informational for you. The outlines are really what the definition software defined is, what are the requirements of the SD-WAN, what are typical solutions today in the market, what really telco needs or an enterprise needs for those are, and where the gaps are. Hopefully we can provide you an overview of how an open source design would be. And then remote site provisioning, monitoring management, and how the backend integration is done. And then we'll summarize it. And at the end, we'll do a full demo to show you the solution. So traditionally, endpoint customers, the CPEs, are very resource-centric. They're very management intensive. There are hardly any zero provisioning. There has to be at least some sort of a configuration effort to be put in. Limited in terms of performance and very static. So a software-defined solution would need something different. So the concept of virtual CPEs has been introduced, which is a software implementation on a general purpose hardware. And those could be at the residential or business premises. Of course, this introduces a much lower overhead. It's a centralized management, so no need for sending a truck roll, a technician on site. Could be a very plug and play and zero-touch provisioning, and the performance can scale because it's not dependent. The application is not dependent on the hardware. Very dynamic flexibility with the ability, and of course, you can add additional functions on that box. So you're not purchasing an appliance with a branded name that can only run that VNF. Now you have capabilities to run several virtual network functions. Now the current industry definition of SD-WAN, personally, I don't agree to this definition 100%, but I'm just going to tell you the industry definition. So SD-WAN is a zero-touch hybrid WAN, private and overlay infrastructure that optimizes packets, forwards it on a least cost-efficient, and is controlled via software. It's sufficient on the wide area network, it's cheap costing, it's overlay, and it's dedicated. Certainly, they use either MPLS or an internet, and they build an overlay service over that to build that connectivity. Usually, the customer premises equipments are cheap. The intelligent routing is how they can monetize and reduce the cost and define the latencies. Of course, a lot of the solutions will use some sort of a controller or a manager to manage those endpoint nodes. And they will have some sort of an integrated solution and security management to provide also an end-to-end management. But I think this is not enough. This is kind of a patchwork. You have your challenges in your wide area network, and you just patched it to get a product out there, but really not a true software-defined. It's more than this. I think the requirements are much, much wider, and we have to look at this and start providing it. I think we broke it into 4 areas, so management and orchestration, security, the functions and capabilities, and of course, operation, which is way more important when you're offering a wide area network service. We'll look at a few of these touch points. So certainly we need a fully automated service. You cannot have a minimal configuration or having a configuration pushed to the device. That's not really what SD-WAN is. It needs to be a fully automated service. It needs to be orchestrated. and needs to be a service-driven. It cannot be a static product. It has to be an end-to-end orchestrated. You cannot have a piece of it done manually and then piece of it by a machine. It just does not delivers the scale. Needs to be able to have the security aspects of being, multi-tenant, role-based access, end-to-end segmentation. The traffic should not be able to leak out to each other, and not only from security, but also from the services you're providing. So it's a multi-tenant instance. Capabilities has to be automated, of course, in terms of onboarding it. So you cannot have, again, spending a lot of time onboarding new VNFs. So the platform should support to onboard new additional capabilities very quickly and productionize it, hopefully in a much agile format. Of course, diverse path routing has been there, but I think it needs to be much more intelligent, not only just on a layer 3, layer 4, but up to even layer 7. So even have intelligent at the application layer. Define those and policies and make it very user-friendly for the customers or user of that service to be able to define them. Transport agnostic and access agnostic is the most important thing for software-defined wide network. It needs to be able to connect from anywhere on any access, irrelevant if it's the same provider or other providers. So it will give the enterprise a unique view, a one-hop access from anywhere to anywhere. It needs to be a full mesh connectivity. In terms of the operation, we mentioned about service operation. Again, it needs to be end-to-end. You have to look at it from the very start till the end. How this service is going to be managed from an operation point of view, patching, lifecycle management. You cannot just think of it, okay, we'll do the fulfillment, but there are no service assurance. So it needs to have that capabilities there. The policies needs to be centralized, cannot be sitting on a localized device anymore, because you cannot manage them, especially if this scales into thousands of devices. It's not scalable. I mean, we're having those challenges today with current wide area network solutions. Of course, the same network operation capabilities being event management, syslog, audit, compliance has to be part of it. It can be a template base, but I would prefer more to be a model base. I think it needs to be a much more model based and dynamic rather than configuration management to define it. And then lastly, the zero touch provisioning here is really about having it detected, configured, and managed without anybody touching it. That's really the target state. We may not be there 100%, but I think we still can achieve that, but that really should be the goal. And we should use that intellectual, analytic that we have, the data, the business intelligence data that we have from routing, from a connectivity, from our operation, and start making decision also on those processes. So and throughout the process maintenance of something fails, able to have the machine heal itself. And again, we're not there yet, but that has to be part of the requirement. Now, we talked about some of these, feature requirements, but again, it comes to the comparison of what it is there today. So today, a lot of SD-WAN elements, really focusing just on a routing path. And the network function itself. But I think you need to think outside of that as well. I mean, because of the software defined, you have way more options, capability available to you by introducing new functionalities, by introducing new capabilities, by introducing different policies. So in a traditional model, you may only have to have one quality of service policy, or you may have one single access list, or you may have one effort of routing. Because in order to modify that, change that, it's not centralized. You have to log into these devices, you have to have a change management and operation. But the beauty of centralized policy is you can change that policy not as an enterprise level, not as a telco level service provider, but even at the individual site level, you can have groups of them. And I think that's the key on that aspect. We talked a few of these things again, and ease of provisioning needs to be multi-site, multi-tenant. I think the major thing that I would leave you guys here is needs to have a common operational model, which is extremely important. And without that, really, the technology is not going to deliver the requirements. So some of the current solution designs today that are in the market, as I mentioned, pretty much, I mean, they're trying to deliver a software-defined wide area network, and they will, utilize architecture like this, but most of them are configuration management tools. They will plug into the wide area network appliances acting as an edge device or a customer premises equipment, and they're just pushing configuration management, duplicating it across. And that's not really a software defined. To me, that is really automation, right? You're scripting, you're managing configuration. The idea of the software defined is more than that. It's really about intelligent that not only it can make decision or push configs to a wide area network device, being an edge router, but also be able to manage it and control it, and then react to that decision, what to do, and push that configuration in real time. So to me, this is a transition architecture. We need to do better.
No, the other way.
And typical enterprise design, I'm sure most of us have seen this. Enterprises will have different accesses. In this case, an enterprise has an MPLS. They're using an internet access as their backup. For security, they'll establish an IPsec point-to-point communication. We'll have a hub site. Everything is into a star topology. Needs to go to the hub site, and from hub site to different SYN. Of course, creates latency, very expensive operation, is very, very, very hard, and scalable, but not very scalable. And of course, every customer will have its own hardware sitting in there. And as you're building the wide area network, more function would need some other appliances. So you need application optimization, you'll put another appliance. You want firewall, you're going to put another appliances. That's another aspects of the SD-WAN. Even though it focuses on a software defined, it's also the network function virtualization. You need to be able to use one set of hardware and have multiple function add into it, right? So it's a very managed service model. You're doing it yourself. To me, again, this is not going to meet the needs of the future. And you'll say, why it doesn't meet? Applications trends are changing. Their needs are changing. The applications are sitting not in the data center anymore. Most of the enterprises are very dependent on cloud services, either being infrastructure as a service, being platform as a service, or a SaaS. So the traffics are no longer at an enterprise data center. It's not about now just a branch site accessing systems and services from the data center, but that branch site has to access the systems from various places. So if an enterprise using Office 365, in a cloud, and they have some sort of a server sitting on a platform, either Azure, Google, or AWS, or even their own partner public cloud, and they may have some services sitting in their public cloud. Imagine with that traffic flow. That traffic latency is going to be so bad, everything is going to the hub, then going out to the internet. So I think that's a reason software defined was there to solve those problems, to be able to have connectivity to local cloud, have the mesh communication, to be able to have direct access to those cloud services. And I think as we're going to discuss that future architecture, and hopefully we'll be able to see how we can solve that.
Thank you, Jaffer. So I think thank you for laying out those requirements, because one of the most important points that you raised is it's not just about creating these diverse path routing and focusing on a config manager. It's about building an open architecture. It's about building, using those open source components so there is absolutely no lock-in. It's about leveraging an existing environment and putting that infrastructure into an existing environment where you're extending the existing set of services. Creating a common orchestration model with what gets hosted inside the data center, with what gets deployed as a virtual CPE in your infrastructure. Creating that horizontal scale model so that you can do better workload balance and workload management. And it has to be flexible and it has to be adaptable. So those principles become incredibly important in terms of how can you stitch or build and architect an open source based software defined wide area infrastructure. So let's take the same picture and see what is possible. Now there's also a reality from a telco's perspective that they have customers that are on net and customers that are off net. On net means that they're on their own network, which means they can provision, they can manage those devices, they can actually configure all of them in a unified manner. But when the devices go sit off net, which means they're attached to another network, and they're communicating over the internet, then you have a set of overlay tunnels and overlay configurations to manage. Now, what you do want is, you don't want a infrastructure manager that actually looks at on-net only and then looks at off-net only, or it looks at off-net but not on-net. You need something that's far more unified. Now, there is a concept that gets thrown around these days called the control cloud. Maybe what you do is you put some of these control applications into a cloud infrastructure that gets hosted somewhere and is unified in managing that entire infrastructure. However, the first thing that you do is first get rid of those appliances, replace that with a white box capability at the branch level, which we call as branch virtual CPE, or a thick CPE model. Then in that thick CPE model, you can host a bunch of VNFs. Those VNFs then provide all of the functionality in the context of things like diverse path routing, things like better QoS, and so on and so forth. Then you actually put the orchestration capability on a centralized side, on some in data centers, that allows you to go and manage these particular virtual CPEs. And if you remember the requirements that Jaffer laid out earlier in terms of the series that you saw, those requirements you can start to check them off to say, well, can we meet this requirement? Can we meet a security requirement? Can you meet an operational requirement? Can you meet a functional requirement? And so on. So then it becomes, once you have that infrastructure, utilizing OpenStack, managing those virtual CPE, creating that management infrastructure across, then to achieve the functionality a typical SD-WAN provides becomes a choice of VNFs. Today, that choice of VNFs is, provided actually on a dedicated box, right? Is a functionality hardware dependent or prepackaged? What do you need? I mean, we work with Rogers, and Jaffer will tell you that majority of my deployments actually are required 2 or 3 VNFs. Is that right, Jaffer?
That's correct, yes.
So majority of the requirements is just 2 or 3 VNFs. So why do you need to complicate an infrastructure deployment model where all you need is 2 or 3 VNFs that are sitting at the edge of that particular network? I know the word edge has been going around in this conference like crazy. Everybody means everything to it, but I'm just going to define it in the context that we're going to use it today. So in that device, or in that virtual CPE, then you can choose what virtual router to deploy or what firewall to deploy. It's a VNF. You can onboard that VNF. You can push that VNF to that particular device, and you can manage that particular VNF. Now it becomes VNF configuration that allows you to do things like secure tunneling, provide better QoS, do diverse path routing. If you have an SDN control environment, you're able to now go manage this particular infrastructure. So choice of VNF becomes important. Choice of VNF will provide you the layered functionality that you're looking for in a typical SD-WAN. Service chaining, that becomes important too. Now, when you have multiple VNFs, how would you actually service chain them together? You may have some VNFs that are residing on that virtual CPE that's sitting out at the customer edge. And you may have a bunch of VNFs that are sitting out in the central side that need to be service chained in order to provide that end-to-end service that you need. Remember, again, back to Jaffer's comments, flexible, adaptable, best of breed, integrated. Well, you can achieve that. You can pick a set of VNFs, you can service chain them, use an SDN layer to be able to stitch those together and create the model that will allow you to deliver that service. Then the next question that comes up, okay, you've shown me that I can use OpenStack as a platform, I can use these set of tools, I can go deploy a virtual CPE and run a set of VNFs over there. What are my choices to run on that virtual CPE? What are my remote site options so that I meet the common objective that he laid out earlier on, which is a common orchestration model, a common management model. Now, you can do an OpenStack deployment a la the Verizon style, which is a micro CPE, or what you have also seen earlier in this particular OpenStack summit about containerized OpenStack capability. So where you have a control plane that's containerized, it runs 2 or 3 virtual machines, you achieve the objective, you have thousands of such small units that are deployed. You need to have some measure of authenticating those, creating some measure of common LDAP model, and managing that distributed type of deployment. The other option might be you actually go to a stretched OpenStack cluster. What do you mean by a stretched OpenStack cluster? You actually aggregate OpenStack control functions in one site, perhaps your localized data center, your metro data center, and then you put those compute nodes out in all those customer sites, and you manage those compute nodes as a distributed compute cluster using that OpenStack. And that allows you some more flexibility in terms of how you place those workloads, how you manage those VNFs, and how you service chain those VNFs. The SDN layer can help you. Or you have a third option where you may not need OpenStack at that particular remote site. You may just want some level of virtualization to host 2 or 3 virtual machines. That was what Rogers had asked, and he stated that a moment ago. If I just have to do 2 virtual machines, do I need the full-fledged OpenStack environment in that edge? Regardless of which environment you end up choosing, from your requirements perspective and from your deployment model perspective, you need the ability to commonly orchestrate across all of them, create a zero-touch provisioning model, and allow you to actually deliver an end-to-end service by configuring all of those. So that brings me to what is that device provisioning option. Now we're going to go into this workflow of the device provisioning in a little bit more depth when Hanan starts to explain how you can achieve that, but that's where our demo comes in a little bit handy. So you can have, for example, a device, a vanilla white CPE box with Linux capability that's shipped to a customer site. It calls home. It calls home and obtains some information, authenticates itself, obtains some information, and then you have the management and orchestration model that allows you to not only push configuration of that physical device itself, or configure even the VNFs that get deployed on that particular device. Remember, what was the SD-WAN value proposition when it came to market? The SD-WAN value proposition was, I don't need a dedicated managed connection from the service provider. I can connect it over the internet. I have a WAN manager. I can do a point and click. It creates an overlay network. It provides you a service. That was the value proposition, correct? Now, that value proposition has evolved because a service provider has laid out a set of requirements and said, no, that's not enough. What I need is an integrated environment. By using OpenStack, by using orchestration and management capabilities with OpenStack, we have actually now developed a platform that allows you, and using an SDN layer, an SDN controller, we've built a platform that allows you to build those capabilities. Now, what you need next is the ability to go provision those devices, automatically attach them to your infrastructure based on your tenancy model, and then create that end-to-end service and deliver that end-to-end service. Then the next one, which is day 2 lifecycle management, also becomes incredibly important. Now, you don't need a different lifecycle management capability, one for off-net devices, one for on-net devices. The whole idea of using open source components to stitch and integrate together and build a service is about creating that common orchestration model, creating that common lifecycle management capability. And you need that not just day 1, which is to provision stuff, but you also need that to evolve on the second day and day 2 and day 3, where you are now managing the service itself. So one thing that he brought out that'll bring it up again, is it needs to be model driven. So then what do? You create a service model, you translate the service model into device models, you take that, and as you change the service, you change the configuration of those devices, and you change the placement of the tunnels or the routes or the paths that allow you to achieve that service that you need. You have different management tools with the flexibility that you have now that you can onboard as part of this particular platform or infrastructure and get that to work. So Netnet, what it would turn out to be, or what would it come to be, is you can have a cloud management platform as an umbrella that allows you to manage that infrastructure both for remote sites and for the central site. At the central site, you use OpenStack as a tool to manage that particular infrastructure, host the VNFs, leverage the power of network function virtualization, and then now use an SDN layer to actually stitch those VNFs together and do an automatic connection to the remote site and create a seamless capability. Now, we can go through the detailed workflow on this, and we were able to show that to working with Rogers, and Rogers was being a great partner in trying to achieve this. And maybe I'll pause here for a moment and ask Jaffer, on this to say, Jaffer, do you think this proposed design that we spoke about, or that I spoke about so far, in terms of addressing those set of requirements, how far it meets your capabilities or your needs?
Sure. So this wasn't part of the presentation. He's putting me on the spot. But I think before I answer that question, I just want to also mention that SD-WAN itself has multiple use cases as well. What we're talking about here is combination of both. Majority of the SD-WAN today are all about centralized virtual network function hosting, and that's where the OpenStack here is hosting the VNF, and then it's service chaining the routing function sitting at the customer premises to the data center and back. It meets some of the use cases, but especially in a large enterprise where they have either lots of traffic going in out of that branch, or they want to have a low latency or control over their services, a thick CPE solution is that has been offered here, which is you're having the virtual network function sitting at the customer premises, but is managed. Both of those functions are managed centralized. In terms of the requirements, Azhar, I think, as I mentioned, those requirements are the best possible solution. And I think today the technologies we have, the capabilities that we have in the open community probably meets 90% and more. And hopefully with this presentation, we are going to create more awareness of what the definition is. And people will have different use cases, and hopefully we'll build in more and more capability to it. But I think it is probably 50 to 60 to even maybe 100, 200% better than what it is there today, right? So the appliance model, certainly not the way to go. A patching configuration management is really not going to solve a problem. I think this is the best model today available, and I think meets majority of those requirements. And hopefully, there are other tools available. I mean, may not be open source, but there are other tools available which can be integrated to these existing open source platforms, and then will build you that 100% requirement that I mentioned earlier. So absolutely, the requirements are achievable. Is it achievable, everything end-to-end at the open platforms today? Probably 90%. But the 10% can be achieved with additional tools and services.
So you believe this is a step in the right direction in terms of how you
absolutely. And again, this is just a technology piece we've spoken about. And then there are other aspects of this, especially at the enterprise and the service provider. The other two big aspects is people and culture. And I mean, we don't have time to go through those, but those are the areas that an organization will go through that. So anybody who is waiting to deploy this or sort of solutions like this, I think you should do that today, because it will take you some time to sort out your processes and people and culture. And by then, hopefully, with the next version, maybe next summit, we will have that 10% capability that's not there. Or we may find solutions. We're still working with different partners in the lab trying to solve those problems. Hopefully we'll come back and give you those answers as well. And we'll put Anand right now on the spot to kind of make it a live demo. By the way, I don't think it's a recorded demo. So if it works, great, we'll take the credit. If it doesn't work, we'll run. But we'll hand it over to him.
Okay. So thank you, Jaffer. So over to Hanan. I think, as Jaffer said, he's going to just walk us through. Yeah. So to walk through the sequence. And
okay. Well, before going to the real demo,
sure.
Just to show what the topology looks like. Okay. We have, in fact, we are emulating here or simulating here a company that is, in this case, is Keep in Touch Corporation, that have a data center in Montreal, and in there we have already installed all the tools that Azhar and Jaffer were talking about. So lifecycle management, for that we are using Red Hat Satellite. For the automation piece, we are using Red Hat Ansible Tower for the automation. And for provisioning, and as well as a single pane of glass, we are using CloudForms. On the other side, on the remote side in this case, this is in Sydney right now. And what you can see there, that is the computer of Azhar, and what we call here the virtual CPEs, that little box that is here, okay? What is going to happen now, what is the next button?
Down, yeah. Slide that down. Yep.
Okay. So, that doesn't show really nice, but okay. What's going to happen is, let's try to follow the sequence. I'm gonna launch from the virtual CPE. I'm gonna bootstrap the virtual CPE, and it's gonna contact the data center back in Montreal and say, I'm here, I need to be set up. And this is when the lifecycle management and the automation kick off. So in this case, the automation will say, okay, I have a new device. This is the profile I have to run on it. In this case, what we want to do is we want to install a virtual router on that device from the data center. So we're going to push that from the data center to the local device here. And once this virtual router, is running on this virtual CPE, it's going to connect to the VPN router on the data center again. So the branch, the remote office will have connectivity to the head office.
So before we actually jump into your screens, Hanan, could you just show what that virtual CPE that you brought on the stage here with us?
It's just custom off the shelf. And what is running in this is just a RHEL 7.4.
And what's the configuration of this device?
This is just a Celeron, 4 cores, and 8 gigabyte of RAM, 120 gigabyte of SD
flash
disk.
drive.
And the only characteristic this little box has is that they have 4 Ethernet connections, not only one. Okay.
So what you're going to do on that as your virtual CPE really is onboard one VNF today. That's the virtual router.
Yeah.
And your data center right now is actually Montreal.
Yes.
Perfect.
And the risk that we are taking is that this little box is relying on the Wi-Fi, the public Wi-Fi that is being proxied by my computer. Okay? So please shut down every single device. And let's see if we can bootstrap this.
Okay, we need to switch to the other computer, please. In terms of
Screen 2, please.
Yeah, got it. Thank you.
Okay. So I'm going to try to bootstrap this. Do you see?
I'm probably going to move away from here.
Yeah.
Okay. So let's see. So what it's doing is generating keys, putting that keys in the authorizations, and calling. Right now, it's already making the call to the data center, say, hey, I am here. These are my credentials, and you see the device is expected to be managed via that IP address. That is an IP address on the data center itself. So if we are lucky, we will see here, this is Ansible Tower, and that's a platform that is being triggered for this, in that case. And you can see here that you have a build site job that is running currently, and this is what it's doing at the moment. The first step is enabling host. I'm going to show you exactly what this looks like, this job template, that you understand what I'm trying to do. In Ansible Tower, you have a workflow editor. So in this case, we are running a workflow. And as you can see, I hope it's big enough for you, it's trying to enable the host. Then it's going to enable the proxy that will authenticate that host. The host is being this one. Then we're going to enable the router. And in parallel, we're going to register the device into satellite.
So what does that registration stuff do, Hanan? I mean, the registration allows you to tell what? Define that device into a tenant, or what is it?
The registration brings 2 things. First is we are using Red Hat Enterprise Linux on the box, so you have to subscribe to enable the packages and enable all the configuration. You have 2 ways of doing that.
So you're doing device updates, and you're doing entitlement, software entitlement.
Exactly. So the first thing you say, I am here, I want to register, and in this case, satellite on data center will feedback, say, okay, you are authorized to enter, you are subscribed. So from now on, you can start getting the updates and getting the packages from the repo.
Okay.
Now,
does it? Yeah.
So one of the reason this is important is about lifecycle management, right? So if we don't do this kind of call management and utilize utilities like this, every time we need to upgrade or patch or change the CP code, somebody has to be truck rolled. Or the customer technician, in this case this is a managed device, so it cannot be a customer, but somebody from the service provider has to go and upgrade those. This is not needed anymore. If I need to patch that systems, and those could be thousands, millions, We just need to push that patch, and a bad job would automatically then manage them as a content. Now, there is a second aspect of this from a security point of view, which we don't have a demo, but we could also have additional security attached to that provisioning. And you're probably very familiar with multi-factor authentication aspects of things. So those could be another solution added in. So not only now we have a device shipped into the customer premises, and if the customer is even managing this or technician, we can authenticate, is that the real person even connecting these CPEs and authorizing it. So again, as I mentioned, we are just demoing it right now, some of the capabilities available, and more of solutions can be integrated to this existing demo that we have.
So back to Hanan. So Hanan, where are we with this?
Well, it's currently trying to register the host into the satellite in backend data center. It's taking a long time, so that is not a good sign. Let's see.
No, it did.
It seems like it registered. Let's see.
Even using a Wi-Fi service that is shared across thousands of people, not very reliable, and far away in a different continent.
Right now into Red Hat Satellite, and let's see if we have now the, oh. Yeah, we just see that, oh, of course. So we have now this 1P6558 is this device that is being registered into satellite. And what you can see here already is that there is a number of patches that are available. You have 19 security issues that need to be attended, 27 bugs, and 2 erratas that can
Excellent.
be, and this can be, I can trigger from here directly, so I'm into the data center, I can trigger from here the update of that device. I'm not gonna do it over the Wi-Fi. I can try, but it's gonna take a while. And the other job that is actually running is let's see, is the other job finished?
Yeah, so in terms of workflow, where are we? It looks like your router is installed.
And the router is installed too.
And is it enabled?
It is enabled.
All right.
The job was successful. Let's see. Now let's try to do something. So I'm going to go to the VPN on the other side into Montreal and see if the VPN as well is up. Okay. And you can see that there is data being exchanged between this device
and you have a tunnel that's established there. That's basically what it's showing, that you have a VPN tunnel that's established from here all the way back to there.
Now, one thing that we didn't speak about, but especially when you're building overlay networks, it gives you that capability that you can use any IPs you want. You can use it as many times you want. Where using an existing internet transport or an MPLS, I mean, MPLS, you'll have that capability, but you cannot reuse the same IPs. But technologies that overlay brings in, you have that as well, part of the SD-WAN here, right? The underlying IP is transparent. It's agnostic of the access. It doesn't matter. It was a Wi-Fi or a proxy. It could be MPLS, it could be internet. The main thing is establish a tunnel, and it has a tunnel end-to-end connectivity.
And I just to check in that we have exactly the same result on the local
both
side.
sides.
Yeah.
Okay, again, see here, that was the IP address he's proxying is 192.68, but it doesn't matter because the communication between those endpoints are based on the tunnel IPs.
Yeah.
So, and the other thing that I wanted to show is, okay, this is what the branch, the head office that's being emulated. This is completely virtualized on OpenStack. And the other tool that we didn't talk much about is CloudForm, where you have, as we mentioned, a single view on all the infrastructure.
Yeah, so maybe you can just take 30 seconds to walk us through what are we seeing on the screen?
So in the screen, I have connect CloudForm to the OpenStack and to satellite. And what you can see here is the distribution of guest OS that are being using on the virtual environment. Of course, this is not only the project I have. On the project I have, I use
you have something else also deployed there. Okay.
There is a cloud.
Okay.
So there is multiple tenants, and you can see what the other guys are doing, basically.
Perfect.
And we have as well on the compute side. Let me see.
from a time point of view, we're almost done. We'll try
Almost
to
there,
speed it
yeah.
up. We're almost there.
Yeah, this is actually what is you are seeing. You were seeing as well in OpenStack. So all the platform that we have been using.
Perfect. Can we switch back to Computer One, please? Thank you. So what you saw there was a way to build, excuse me. No, sorry. So what you saw there was a way to build an SD-WAN using as many open source components as possible and integrate that with your existing NFV deployment infrastructure. Use an SDN layer to service chain those VNFs together, fit it into an operational model that you're familiar with respect to providing VNF as a service, without having to resort to any proprietary capability or connections. And your context on diverse path routing, on QoS, then becomes a function of the VNF that you choose, which is your vRouter. So what we're really trying to say is SD-WAN is more than just diverse path routing. SD-WAN is a way to deliver a capability and a service, and you can use the open source tools to actually build that kind of infrastructure and provide that capability and deliver that service. Any last words, Jaffer?
So again, this is just a teaser. I hope you guys can start investigating the solution on your end as well. We haven't published any of these publicly, but maybe one day we'll do. Now, another buzzword you've probably been hearing almost for 2 years now is containerized. So one of the things that potentially we will look at it as well is how can we containerize this virtual CPE at customer premises. It is something that we will target. It has its own benefit as well. But it's not just because what we have shown here does not meet the requirements. Containerized will give us a little bit more flexibility when the native VNF is going to be introduced. Right? Today, a lot of these virtual network function in the market are really existing appliance codes just virtualized to some sort of a virtual machine. But as the industry is going to mature enough, there'll be much more native cloud services will build. We'll use architectures of microservices. Will allow us capabilities to use containerized to only grow certain functions, provide us more security. And that's really what I want to kind of say. This is just a start. I think we will build upon this more and more use cases. This is just a start. And hopefully with edge computing buzz, a lot of new use cases will build around this as well.
Thank you very much. Thank you, Jaffer. So we hope you like this presentation. If there are any questions, we'll be able to take one or two before the time expires. Yep.
I'm just curious, it was a very impressive demo and very good presentation. I'm just curious, what SDN controller were you using to provision the view?
So in this particular demo, we are not using an SDN controller because, as you saw, he's been doing the onboarding and workflow through the Ansible. However, internally, as part of our setup, we've discussed Open Daylight as an option. We've also discussed third-party SDN controllers as an option as well. Jaffer, you want to say?
I think SDN controller is a very key element in any software-defined networking. There are some open platforms, as I mentioned, and you can more than free to use them. From my point of view, they lack certain capabilities, but they deliver those 90%. I cannot tell you which one we use today because we haven't announced that. It's a confidential intellectual property. But I can tell you what are the requirements you should be looking in for an SDN controller. Certainly, you do not want to build duplication of functions. You cannot have an SDN controller managing your data center and an SDN controller managing your edge device. You cannot have an SDN controller for single platforms, right? One managing different sets of VNFs, the other. You should be targeting to pick a single function as much as possible. Etsy's reference architecture also has many other things part of the solution, like being element management functions and others. I think you should also use that Etsy just as a reference architecture. I don't think they're 100% correct as well. So in our solution, we do not use element management to manage those VNF. There's another component that we didn't talk about in the solution is about, VNF management, lifecycle management. What happens to the actual VNF itself? How are you going to patch it? How are you going to upgrade it? What version of code you onboard it? So again, these are build-up capabilities that I mentioned, the 10%, that you need to look, and every one of us here will have different set of requirements, and we may pick different vendors to deliver those. But majority of the stuff that we use here, we're all open platform. They're available today for you. You can certainly go, set your lab, play around, and you can achieve the exact same use case we have just demoed here.
One more question, probably last one.
So how do you solve the initial bootstrap issue? Like, are you using iFixie with Ironic, or like, are you just reloading the CPE?
How do you solve the bootstrap issue? Are you currently preloading it, or are you going to do some sort of
The bootstrap should be preloaded. I didn't do it right now because the demo, but you can already include it when you are installing the operating system.
By the way, the architecture here is, again, thinking outside the box. Rel Manager today is used in data centers for customers to manage their workload. We took the same kind of approach to now manage virtual CPEs. So it doesn't mean that we reinvented the wheel. We just invented a different use case. And this is, again, my message would be is, just don't take something just built for that. You can always find, other alternative solutions for the exact same ingredients. And I think that's the beauty of this conference is you'll meet other people that have used the exact same tools, but in different use cases. And I think that's where our mindset around this presentation was that tools or capabilities are there. They've been there for some time, but people are not using it. So that's really was the message here, to give you that aha moment to say, hey, it's been there, I have it. Why did I not think about it? And that's what we have done here.
Thank you very much, ladies and gentlemen, for joining us.
Thank
we hope
you,
this is useful.
Sorry.
Sorry, go on, Hamid.
No, and enjoy Sydney. And by the way, we have amazing flip-flop outside, just at the entry, so enjoy. Don't leave the room without a pair.
By the way, in
And
Australia,
guys, if you have questions, you can find us. We can are more than happy to answer them.